Okay, so let's take your attendance first, huh? Okay, class. So we start today's lesson. Eh? Okay, so I think today I asked you to do the trial papers, right? Okay, I asked you to do the trial papers. I think these 4 papers, right? AS trial paper 2 Gen 20 and AS trial paper 1 August 20, right? Eh? Okay, so first we go to the paper 2. This is the question you tried, right? Okay, normally paper 2, the mark scheme should be quite helpful, but still, anybody got any problem after you check the question, after you done and check the mark scheme, you have still don't understand? Anybody? Is paper 2?
Can you explain question 2B?
2B, huh? Oh, this part, okay. So car mass 1,100 kilograms traveling up a slope, incline at 10 degrees at the horizon from an initial speed of 10 meter per second to final speed of 15. Okay. Determine the work done on the car during this time when the speed of the car increases. Okay, this is fine. B, what is the useful output power of the car engine when it's moving at a constant speed? So the car subsequently moves with a constant speed of 15 meters per second. The combined frictional force acting on the car are directed down the slope are equal to W over 5. Or this is W over 5 is the frictional force acting on the car, the combined frictional force, W over 5, where W is the weight of the car. Okay. So it's moving with a constant speed. Okay, what is the useful output power of the car engine when it is moving at a constant speed? Okay, this you have to check with the. Okay, I think easier we straight go to the. You don't understand the mark scheme, is it, Ashley?
Yeah.
What mark scheme is it? So rate of potential energy gain is sorry, B, right? Yeah, net force is 0, net force of the car. So this is the car force. Useful power output is 60.5 kilowatts. Okay, but okay, I think I teach you in this term. I think what I told you most of the time, I said whenever they're asking for inclined surface, okay, inclined surface, work done by the thrust is equals to what? Gain in EP, gain in EK, heat, right? This is the universal equation, right? Okay. So the question asking useful output power. They want useful output power. Okay. Of the car engine when it is moving at a constant speed. Okay, useful output power. Useful output power is the gain in the useful output power is actually it doesn't increase its kinetic energy. So here the wording is different. They're asking because they're asking for power. If this is all our energy, first we change them to power first. The power is over time. It's all over time. All over time. Okay. So engine when it's moving at a constant speed. So they want output power of the engine actually. They want the output power of the engine. Okay, they want the output power of the engine. That means they are looking for this. This is what they want output power of the engine. So work done by the thrust over time. This is the output power we are looking for. Output power of the engine. Okay. So it's the same as this 3 energy over time. Okay. So what is the is it gain kinetic? It doesn't gain kinetic because it moves with a constant speed, 15 meter per second. So the total output power of the engine is the gain in potential energy over time plus heat over time. Okay, so this is output energy. Okay, I'm showing another way of doing it. The what do you call the formula I introduced you when I teaching you this topic. Okay, so the output of the power of the engine is equals to gain in potential energy is how much? Is mgv. mgv, the potential energy over time, we can write as mgv. Is actually mgh over time. The h over t, it tend to become v. Okay, but this v, do they give the slope? Oh, this v, the v we are writing here is the velocity, vertical velocity. But the velocity given here is the diagonal velocity, 10 meter per second, and an angle is how much? Sorry, the diagonal speed is 15 meter per second. What is the angle? The angle is 10 degrees. You can put 10 degrees. That means here the h over t is the vertical height, vertical height over time. So here we must use the vertical velocity. The diagonal velocity is 15. Its vertical component how much? The Vy. Vy is supposed to be used here, the Vy. Okay. So mg Vy, the vertical velocity, or in this case, mg times 15, sine of cos should be sine 10. Should be sine 10 degrees. This is mgh over time, plus with heat over time. Heat over time is actually, heat is what? Heat is force times distance travel over time. The s over t is v, 15 meter per second, the actual speed. Okay, because friction acting diagonal on the surface, and the 15 meter per second also parallel to the surface. So the s over t is v. So this we can write as sv. Okay. So this is another way of doing. So yeah, the friction is how much? Friction is W over T, W over 5. This is W over 5. Weight over 5 is the force, the frictional force, times V is 15. Okay. This is W times 15 sine 10 plus this is what? This is 3W. Okay, what do you get? W is how much? What is the weight of the car? Is it weight given? 1100 kilogram. 1100 kilogram. Okay. So the weight here is of course 1100 kilogram multiplied by 9.81 times 15 sine 10 plus 3, the same value. 1100 times 9.81. This is another way of doing. What is the power you get? Somebody can calculate for me this. Do you get the answer? Same answer. Yeah, just give a try. Try to calculate this. 1100 times 9.81 times 15 sine 10 plus 3 times 1100 times 9.81. Anybody? Give a try. Calculate first.
It's 60,480.
60,480. Yeah. So you get this value 60.5 kilowatts. Okay, so yeah, this is another way of doing. Okay, but when I teach in the class, I taught this way. Okay. So the useful output power of the engine is the work done thrust over time. This is the output power of the engine, the engine output power. Okay. So output power is actually divided by time. So here K becomes 0. So only EP over time plus heat over time is the output of the engine. The EP is mgh over time, but the h is a vertical height. So it should use vertical component of the speed, Vy. Okay, the diagonal one is 15. You have to use the Vy, the vertical velocity, because this is the vertical h is a vertical height, so Vy. So 15 sine 10 to be used, vertical component. And the heat over time is actually Fs over T, but this S is the diagonal distance travel, So S over T is actually the 15 meter per second, the actual speed. So you calculate this, you get the output power. So you got 60.5 about 60.5 kilowatts. Okay. So actually, any parts you don't understand?
I get it now.
I think this formula is quite universal. If you want to go power, you can go power. Just divide by time. You want to go energy, then just don't divide by time. Okay. Okay. Any other questions? Paper 2? No questions.
Question 4B.
4B, Okay, question 4B. Wave. Using the result from your table in A, determine the wavelength of the helium cadmium laser. Using the result from your table in A. So we want to find wavelength of the laser. What result in the A? The result is, so this is what? This is the diffraction rating. A laser hit the diffraction rating and you get the first order maximum. So this is the first order maximum. So we want to find, okay, the diffraction grating has a grating of 300 lines per millimeter and 2 meter rule. Okay. So this is the zero order and this is the first order. First order got 3. The result obtained by the student, the images indicated the position of the central and the first maximum seen on the meter rule. Oh, you have 3 readings, repeated readings. Oh, no, you see. So it's exactly 0. So you get here. So you need to find the average distance, average distance. So B. First answer you get what? Determine the angle of the diffraction. You got the angle, right? Using the result, determine the wavelength of the. So what formula do you use? D sine theta equals to n lambda, right? To make it fast. Yeah, so D sine theta equals to n lambda. So identity, of course, n you use 1. D is 1 millimeter over 300. 1 millimeter over 300. Okay, but millimeter change to meter, so times 10 power negative 3 on top. So you get the D. Correct substitution of formula of wavelength. Theta you already know at part A. What? Part A you already know the theta. So you substitute, you get the wavelength. Okay. Which part you don't understand here? Ashley.
I didn't get the answer.
Oh, you got a different answer. Oh.
Yeah.
What's the answer you got for the wavelength? Wavelength. Yeah, they didn't give the wavelength. The wavelength answer is not given here in the mark scheme itself. But they just show the what are the input you give. Answer is not given. They ask you to prove, right? Did they ask you to prove? No. What is the answer you got?
I got 0.131 meter.
0.131 meter. You got 0.131, 0.131 meter. Any power times 10 to the power of something? No, don't have.
No.
Okay, because the visible is what? 4 times 10 to the power of -7 meter to 7 times 10 to the power of -7 meter. So your reading, your answer must fall in this range. But what's the mistake? So your lambda is what? So we rearrange the lambda as lambda equals to d sine theta over n. So d is this. So this is your d, is it? 1 times 10 power of. Yeah, makes sense. So this is your d, 3.33 times 10 power of -6 sine theta. Theta, the answer you got above. The angle you got here. It's all without values. So shift tangent average value of the fringe divided by 1. How much the theta you got?
I got 7.52.
7.52 degrees. So here 7.52 degrees over n1. Yeah, you should get -7. But you try and see sine 7.52, how much you get? Times 3.33 times 10 to the power of -6. I think you should get around 10 to the power of -7 if I'm not mistaken. Looking at these numbers.
4.4 times 10 to the power -7.
Okay, 4.4 times 10 to the power -7. This looks okay, but it's in a visible range. Because the answer is not given here. They just giving marks for the substitution. So 4.4 times 10 to the power -7 is relevant because it falls in this range. So under visible range. Okay.
For the question above, do I find the average of all three angles of diffraction, or do I find the average of the distance?
Average of the distance.
Oh, okay.
Average of distance, yeah. Okay. The others, guys, any questions about this part? Nobody? Okay. Okay, that's part B. B. Any other questions? Okay, we don't have questions, then we go to the paper 1.
Can you explain 5C, the difference between volt and electron volt?
5C. Would the electron be able to reach the negative plate? This is the question, right?
Yeah.
Would the electron be able to reach the negative plate? Show your working. Okay, so electron able to reach the negative plate. So electron, is it electron able to reach the negative plate? Negative plate is on top, electron is, okay. Electron kinetic energy directed, it has, electron has this kinetic energy. It has this much of kinetic energy. It was directed upward, but of course it's going to repel downwards, because negative plate on top. Okay, they asking, is it able to touch the plate or not? So how to know whether the electron going to touch the plate? That means what's equals to what? The kinetic energy of the electron must be at least same as the work done against the field. You must check how much work need to be done for this electron to touch that plate. What is the work need to be done? Then you need to calculate first. Okay, if the electron to touch the plate need, let's say 10 joule. So the kinetic energy of the electron, if it's more than 10 joule, then it should reach the negative plane. So the clue is what? The work done. The work done against the field must be smaller or equal to the kinetic energy possessed by the electron. This is the idea. This when it can touch. The work done against the field must be smaller than the kinetic energy possessed by the electron. Okay. So the kinetic energy of the electron, they already said is how much? It's 7 times 10 to the power of 2 eV. So it's 700 eV. EV, I told you, is a unit for energy, electron volt. Okay, we leave it as EV. We leave it as EV. Okay, so now we get the work done against the field. How much the work done against the field? Work done, what's the formula? FD, right? Work done. Force times distance travel. Okay, force on the electron. So force on the electron, how do you can find? Q times E, the charge of the electron times the electric field strength, times D. What distance is travel? What distance is going to travel from the center to upward? The distance you should travel half of 5 centimeter, right? So the distance you need to travel is 2.5 cm. So the D is 2.5 times 10 power of negative 2 in meter. And check this value. Check this value. You will get in joule, but you have to convert this joule to EV. Or what you can do, leave here as joule, convert the 700 to joule just to compare. Then you can check. You can get the answer. I think 700 EV change joule. Joule is easier. How do you change EV to joule? EV to joule, you multiply by 1.6 times 10 power of negative 19, right? So you got into joule. Check. If the work done is smaller than the kinetic energy possessed, it will reach the plate. Okay, so this is the idea. This is the idea. Okay, let's go to the mark scheme. See, mark scheme, what is it? Mark scheme is so mark scheme using energy method. The kinetic energy is 700 eV. The potential difference from the center to the negative plate is 1250 V. In order to the electron to reach the negative plate, it must have at least 1200 eV of kinetic energy. It will not reach the negative plate if only as 700 eV. Okay. Okay, so here they give okay, up to here you understand lah. It's as a kinetic energy of 700 eV. 700 eV. Sorry, 700 eV. Okay, now they give another choice. Another choice what? They give kinematic method. I go for energy, easier. Okay. So because that's 700 eV, because kinetic energy is 700, potential difference between negative plate is 1250. Okay. In order to electron to reach the negative plate, it must have at least 1200 eV of kinetic energy. How they got this? 1250 eV. Correct, right? The plate is here, the center. From center to go up here, what is the work done? What is work need to be done? I told you just now FD. But do you still remember? I told you when I teach this topic, the FD, the F can be written as QED, and the E and D can be merged become QV. Do you remember? The work done in electric field is QV. QV is the changes in the potential between these 2 points. Okay. From the bottom to up, what is the potential difference? Bottom to up. Bottom to up, the potential difference is how much? 2,500. 2,500 potential difference. 2,500. So the total potential difference from here to here is the potential difference. Changes of V is how much? 2,500 volt. So from center to go up, the potential difference is 1,250. 1,250. Half of the 2,500. So then what is the work done to go up? What is the work done? Work done is Q times V. Q of the electron is E. The V is how much? 1,250 V. So it's going to be 1,250 EV. This is the work need to be done. 1,250 EV need to be done. But the kinetic energy possessed by the electron only 700 EV. For the electron to reach the plate, it must have 1,250 EV. So it would not reach the negative plate. It only possesses a very little kinetic energy. The work done is 1,250 EV. If you don't understand this working, I show you here just now. This is working, right? Will it do that? You see this energy, this QE times 2.5 times 10 to the power negative 2 joule, right? You convert to EV and C, you'll get 1250 EV. So the work done against the field is greater than the kinetic energy possessed by the electron. So electron cannot reach that plate because lots of work need to be done. The electron don't have that much of energy to do work. So you'll stop halfway. Okay, actually you got the idea. Which part you don't understand still?
No, I get it now.
You get it, Okay. Okay, guys, the others, do you understand the explanation I give you this part? If you done this question, maybe you, any questions? No questions? So any other questions other than this from this paper? No. 6. Okay, no questions. No questions, we go to the paper 1. Okay. So those who done, I believe all of you done this paper. I believe you mark the question paper. You must, of course, our target is to get a star. So your route, you should get at least how much? 45 over 60. This is the target. Okay, this is your target. Okay. Let's say now you got only 30 out of 60. So you have to do more papers until you stabilize at 45. You stabilize at 45, like few papers you get 45 and above consistently. Okay, yeah, you are in an A-star category. Until then, you have to keep doing as much as you can. Some students, they just do 5 papers, they can achieve this 45 and stabilize that. Some students need to do 20 over papers to achieve that. So every student is different. So don't stop doing the papers until you stabilize at 45 at least out of 60 to secure A star. Okay, so we go to the next paper then. We go to the next paper, paper 1. Okay, paper 1 is this one, right? Yeah, this is paper 1, right? Okay, so this paper, this is the paper, right? Okay, what is the ratio of 1 millimeter or 1 gigameter? Just one first question. Any questions? Got problem? Yeah. After you're done, check mark scheme. Don't understand.
Number 18.
18. Okay, 1-8. Okay, those who the others also still try to have some idea. Maybe you will face the same problem. Okay, 18. Deformation of solid. A table give data for the yield stress, breaking stress of copper and aluminium. Oh, yield stress for copper is 70. Yield stress means you get into the plastic region. To get into from elastic deformation to plastic, you need to apply 70. But they haven't break yet. But when you apply 220, the copper wire will break. Okay, looks like aluminium has a greater strength. It has a greater strength compared to copper. And aluminium looks like has a greater range of elastic deformation. Because only 241 is start to change to plastic deformation. 241. Okay, a force of 140 Newton is applied to a copper wire. 140 Newton or 140 Newton, it is in in the middle of plastic deformation. Applied a copper wire of cross section 0.5. The same force is then applied to aluminium wire at the same cross sectional area. But aluminium under 40 is still under elastic deformation. But copper already in plastic deformation already. So which statement about the two wires is correct? Both wires will permanently deform, but neither will break. Both wire will be permanently deformed. No. Copper wire was permanently deformed, right? Because under 40 Newton, you have to check. You have to check which deformation it is. Under 40 Newton for copper is already here, okay, in a plastic deformation. So copper is already plastic. That means plastic means never return back to the original length. It will have a permanent deformation, right? So A wrong. Both wires will permanently deform, but neither will break. Both not breaking, but only copper is permanently deformed. Both wires will break. No, both wires won't break. To break, you must exceed more than under 300 and 220 respectively. This is only under 40, so never break. The copper wire will permanently deform, correct? Because under plastic deformation. But aluminum wire will not. Aluminum wire will get back to the original line because it's still under elastic deformation. Because yield stress is 241. So under 40 means far lower than 240. So still under elastic deformation. So it will get back to the original line. So C looks correct. The copper wire break and aluminum will break. No, C is the answer. Okay. Riyad, you got idea? Which part you don't have
the stress?
Yeah. Yeah.
You don't have to calculate the stress.
No need to calculate the stress. This is just, they already give the limits. So what do you understand by yield stress? Yield stress means this is the cutting point. This is the cutting point where at 70, the copper will get into the plastic deformation already. Sorry, plastic deformation.
I didn't understand the MPa.
Oh, MPa is megapascal. MPa is the megapascal, the amount of stress applied, megapascal. So if copper, let's say this is your pressure stress. I put stress. Okay, this is not 70. Here 70. At 70, this is the extension. This is your elastic deformation, right? This is your elastic deformation. After 70, you should understand it get into the plastic deformation. So after 70, it can't go back to the original length. You'll have a permanent deformation. Yeah.
But that's the answer. You can use the force. Why can't you just why do you have to use the force? I thought you had to calculate the stress to find the
Oh, you want to calculate the force, is it?
No, because you use the force.
Yeah, sorry. What I'm doing. Yeah, guys, sorry, I also stuck there. You need to calculate this is megapascal, this is force. So you need to multiply with the area first to calculate the stress. 140 times 0.5, how much you get? 70.
So it should be divided by 0.5.
Oh, yeah. Yeah. So force over area, right? Yeah. So 140 divided by 0.5, what do you get? You got 280, 280 and 0.5 times 10 to the power of -3 some more. How much you get? 140 divided by 0.5 times 10 to the power of -3. You got 280 megapascal. Oh, then sorry, answer won't be there.
It should be -6, right?
Oh yeah, -6. Okay, yeah, correct. Good. So force is 140, 0.5 times 10 to the power of -6. So how many megapascal you get? You get megapascal, right?
280.
280, yeah. 280, yeah. Yeah, 280. Oh yeah, sorry. Yeah. So 280 megapascal. The cutting point is 280 megapascal. So copper will break Copper will break, right? Aluminium will be plastic deformation. So both wire will permanently deform. No, both wires will break. No, the copper wire will The copper will break. Aluminium will be permanently deformed. So then D is the answer, correct? Yeah. Oh, I didn't see the megapascal. Yeah. Kiria, got the idea?
Yeah.
Okay. Earlier, why you don't understand? Which part you confused? Oh, the Newton to megapascal.
Because my answer was really big, but I didn't know it was supposed to be in megapascal. So.
Oh, it could be Pascal too, but Pascal is a big number, so we change to mega.
Yeah.
Any other questions, guys?
Number 20.
20, yeah. Okay, 20. 1 kilogram mass is hung from a wire, resulting in a small extension. A wire is made of same material and has the same length, but twice the diameter of the original wire. Twice the diameter of the original wire. So first wire has what? Has a length of L. Length of L. So hung 1 kilogram. We hung 1 kilogram of mass. Small. A second wire is made of the same material and the same length, but twice the diameter. Okay. So diameter is the culprit. The first wire, let's say we put area. We don't want diameter. So first wire, let's say area A. The second wire, because diameter is double the diameter. So area should be how much? Area should be 4A, right? Twice the diameter. Diameter double, area become squared, D squared. So 4A, area is 4A. Okay, other than that, the second wire is made same material as the same length. Oh, this also has length L. This also L. Diameter. What was mass hung on the second wire will produce the same extent. Oh, they're asking what mass to be hung here so that their extension is the same, both as the same extension. So that's right. Okay, let me. So what do you do from here? So what is same? Extension is the same. So Young modulus, of course, you think about Young modulus, force over area, extension, original length. Okay, this is the formula to be used, right? Okay, a little messy. Let me open up the whiteboard, maybe. Do it here. Okay. So we use this diagram. This diagram. So extension is what? Okay. Okay, so extension is what? Extension, you rearrange this formula, extension, so FL over EA. So because extension for the both wire 1 and 2 is the same, first wire, second wire. So put the values. The force, okay, the force is the mg, okay. For the first wire, m is 1, g is the gravity, I put g, L is L, Young modulus is E, I put E, area is A. Okay, for the second wire, the mass we don't know, I put as X, the mass is G, L is L, same E because same Young modulus, both made of same wire. Only the area is 4A, right? Okay, so X must be how much? 4 kilogram, right? Correct. Answer, is it given D? Is it D, the answer? Ria, is it D?
I'm not sure. I didn't check the answer.
Okay, check for me. What's the answer?
The answer is D.
D, yeah.
Yeah.
So D. Okay, so D. So this is how it's working should be. This is working. Which part you don't understand still?
I understand now. I just forgot how to do it before.
Okay. The culprit is the diameter. The diameter convert to area. Diameter double, area is 2 squared. 4A. Okay. Okay. So I'll give you 1 minute to take down. I think you can look at the video later also. Any other questions?
So 34 can explain again. I got the answer, but I'm not sure about the working.
Which number?
34.
34. 34.
Yeah.
circuit. Okay, the others, come on, give a try. 34. The figure below shows a network of 3 resistors. 2 of these marked R are identical. The other one has a resistance of 5 ohm. Okay. The resistance between X and Y and Z to be 2.5. Okay. So, okay, resistor Y and Z, Y to Z. So you start your journey here, your current start here, Y, and finish at Z here. Okay, so it's found to be 2.5. So you need to check what is 2.5. You start from Y to Z. How many ways? Let's say you like electron. I told you, like, you imagine like driving a car. You start your journey at Y. That's your house. The destination is Z. How many ways you can reach the Z? Just this is one way. One way, passing the 5 ohm is one way of reaching the Z. Another way is what? Another way is second way, going to the R, X, and go to the another R and come to Z. These 2 ways. These are the 2 ways leads to reaching the Z. So imagine like that. How many ways can reach the Z, the destination? So these 2 ways is like a parallel route. Parallel route, find the resistance parallel. So the first route, what is the resistance? 5 ohm. So the effective resistance, the 1 over R YZ, YZ should be equals to Y to Z should be equals to 1 over the first root is how much? 5 ohm plus the second root how much? 1 over 2R. This is the conclusion made from this 2.5. So 1 over 2.5 is equals to 1 over 5 plus 1 over 2R. So from here, work out your R how much? How much R? 205, 105. So R you get 2.5 ohm, if I'm not mistaken, 2.5 ohm. Yeah, R you get 2.5 ohm. So R is found to be 2.5 ohm from this working. Correct? Okay, now what is the resistance between X and Y? So now you start your journey at X, you finish it at Y, finish it at Y. So imagine now, what is the new route? This is the first route. First route got resistance of 2.5 ohm. Second route got R and 5 ohm. These two is parallel. So 1 over R X to Y is equals to 1 over 2.5 plus the second root how much? Total resistance? 7.5, right? 1 over 7.5. Here 2.5, here 5, so 7.5. So 1 over 2.5 plus 1 over 7.5. This is the 1 over R XY. For me, you work 7.5 is what? I think you got 3 plus 1, right? 3 plus 1. 1 over R XY. So R XY is what? 7.5 divided by 4. How much you get? 7.5 divided by 4, what do you get? 1. 1.8 something or 1.85. Is it C the answer?
C is the answer.
So yeah, this is the working. You got the idea?
Yep, got it. Thank you.
What's your name? Daniel.
Genuine.
Genuine. Okay, genuine. Okay. So you start from where to where? So if you start at Y to Z, you imagine like you're driving from Y to Z. How many routes are there? The routes are considered as parallel routes. So you take them as parallel resistance. So you add them parallel. Okay, so 1 minute for you to take down. Come on, before we go to the next one. Okay, so any other questions?
Number 28.
28, eh? Okay, so let's proceed to 28. Okay, so yeah, hope you already take down, or maybe you can watch the video later. 28. Okay, this one. A thin beam of monochromatic light falls on a diffraction grating at a normal incidence. The third order diffracted beam occurs at an angle of 50 degrees to the normal. What is the highest order visible with this grating at this wavelength? This is a diffraction grating. So formula is d sine theta equals to n lambda. Okay, the question wants what is the highest order. So for the case of highest order, okay, it means n max, n become max. What become 90? And n become max. The sine becomes sine 90. Because diffraction grating is the first order, second order, third order. The maximum order you can observe is at 90. So 990. So n max is actually d over lambda. D over lambda will be the n max. Check the d over lambda. Okay. So now, how to find d over lambda? I think we get it from the first set of reading. The angle was 50 degrees for third order. So from here, up here, d over lambda is what? N over sine theta. So d over lambda is what? And third order happens at sine what? Sine 50, yes. So d over lambda is actually 3 over sine 50. So that should be your n max, right? D over lambda is your n max. Right? So d over lambda is 3 over sine 50. What do you get? 3 over sine 50. Check, anyone? 3 over sine 50, what do you get? Check for me. 3 over sine 50. Anybody?
$3.92.
Okay, it's 3.92. Okay, yeah, so 3.92. So n max will be what? N max will be an integer. You can't round it to 4. You always round down. I told you this in the when I teach this topic. 3.92 means the fourth order not fully visible. So you have to round down. So it's 3. Answer going to be A. You can't go for 4. Don't round up, round down. 3.92, the fourth order not fully observed, so not accepted. So third order is the maximum order. Okay, Riyad, you got the idea?
Yes, sir. Can you explain number 29 as well?
29. Okay. Okay, we go to the 29. The diagram shows a string, its ends P and Q fixed. The string is made to vibrate transversely. So P, Q, and R are only points on the string, which are nodes. P, Q, and R. P, Q, and R are nodes or nodes. Okay. S and T are 2 points. equal distance x from R. Okay. Okay, which statement about the vibration of the 2 point S and T? Okay, this is a stationary wave, right? This is stationary wave. So the wave, I think, moving like this, right? I don't know. Maybe few loops can happen, but so I think should move like this, right? It vibrates vertically. The P, R, and Q like nodes. Nodes. Nodes is a point where the amplitude is 0 due to destructive interference. So the point S, let's say on top here, the point S means the point T, the particle at T will be here, down here. Particle. Because they are same distance away from the node, they always will travel in opposite direction. So they have a phase difference of 180. And they will have the same amplitude because you see, because they separated from the node the same distance away, their amplitude will be the same. They will have the same amplitude. Okay. So which answer going to be? They have different amplitude. No, they have same amplitude because they from the node they are same distance away both sides. Okay. So you have a stationary wave from the node. If with the particle A, there's a particle B. If the same distance here, one is also one distance away, then particle A and B has the same amplitude. The amplitude will be the same. Okay, so they have different amplitude. No, they have the same amplitude. They have different amplitude. No, different amplitude, not the answer. Either C or D. They have same amplitude and are in phase. They are not in phase. They are out of phase because the first loop going down means the second loop will be going up. They always phase difference of 180. Okay, so of course D is the answer. They have same amplitude but anti-phase, phase difference by 180. Okay, all the particles of the first loop, second loop, all the particles of the first loop and second loop has a phase difference of 180. Okay, all the particles of the first loop and the third loop, phase difference is 0, no phase difference. This is only applicable for what? Stationary wave. Stationary wave. Not applicable for progressive. Progressive wave. How do you find phase difference? Use the two formula. How do you find phase difference for progressive wave? The phase difference is x over lambda times 2 pi, or what? T over period times 2 pi. This used for to find phase difference for progressive wave. Progressive wave. Stationary, no need to calculate. Either 180 or 0. Adjacent loops 180. Like odd number of loops, 0 phase difference. Okay, Riyad, you got the idea?
Oh yeah.
Okay, the others got any confusion about this? Okay, hope you got the idea. Stationary wave, progressive wave, different rule. For phase difference. Yeah. Go and study hard about the difference between stationary wave and progressive wave. Okay, stationary wave, all particles have different amplitude. Progressive wave, all of them have the same amplitude, and so on. Got few differences. Try to understand it by heart. Okay. Okay, take down this before we go to the next question. Okay, so any other questions?
30.
Yes, what number? Ashley?
30.
30, yeah. Okay, 30. Okay, wave again. 30. To observe interference fringes formed by a double slit placed 2 meters away from a screen in an experiment of Young double slit experiment. What would be the best value of slit separation? Okay. What's the answer given? B. 0.32. What's the answer given actually? 0.1.
C.
1 mm. Oh, 2 meter. What would be the best value of slit separation used? Okay. Okay, see, lambda equals to ax over d. We want to find the question asking for what? This question asking for the slit separation. Slit separation is the A. The question asking what A to be used. So double slit asking what A to be used. Okay, so that we get a nice fringe which can read very clearly. Okay, so we're looking for A. So it's lambda d over x. Okay, so lambda, we know lambda is fall between, what is the lambda value for visible light? 4 times 10 power of negative 7 to 7 times 10 power of negative 7, right? In meter. Okay, let's say I put 4 times 10 power of negative 7, let's say. The d is what? D already said it's 2 meter. It's 2 meter, so we put 2. Okay, we want to find the A. We want to find the A. X. Okay, see, whenever in a double slit experiment, the fringe which is formed, fringe means what? The dark to dark, the separation, the fringe, the X value. Okay, when the scientists want to measure this D, they want this X to be not too small. They don't want to be too small. They don't want it to be too small, and they don't want it to be too big. Too big means not the D like 1 meter away. They don't want the D to be like the X like 1 meter away because the screen is not 1 meter length. They were happy to see the fringe as in terms of maybe a 5 centimeter, maybe 10 centimeter, within centimeter now, because within the ruler range. Ruler, maybe use the 30 centimeter ruler. So the D is like, first dark happens and second dark happens within a 10 centimeters. In terms of 10 centimeter, maybe 10 centimeter is ideal. We don't want the D to dark to happen in a 1 meter. One D and another D is 1 meter. So on the screen, the screen itself, maybe the length is like maybe less than 1 meter, less than 1 meter. So first dark happen, second dark already out of the screen. So we cannot measure. Okay. Or the D is like too close, like 0.01 mm, also very bad. We can't read, we can't measure it by using a ruler. Best is around 10 centimeter. Okay, X we put 10 centimeter. We put X as 10 centimeter. Centimeter, X in centimeter is how much? 1 times 10 to the power of, 10 times 10 power of negative 2 is 1 times 10 power of negative 1, right? Meter. Just put, we prefer the X to be like in terms of 10 centimeters. We put 10 centimeter. What is the A value you get? Is try and error. So 4 times 10 power of negative 7 times 2 or 1 times 10 power of negative 1. What do you get? Someone? Anybody? 4 times 10 power negative 7 times 2 over 1 times 10 power negative 1. So you get 8 times 10 power of what? Negative 6, right? Negative 6. 8 times 10 power negative 6. 8 times 10 power negative 6. It's quite big also, meter. 4 times 10 power negative 7 times 2 over X is 1 times 10 centimeter. 10 centimeter is 0.1. 1 times 10 power negative 1. So A, how much you got? 8 times 10 power negative 6. Yeah, negative 6 meter. This is, in millimeter, will be 8 times 10 power of negative 3 millimeter. It's like 0.008 millimeter. Oh, it's quite small. It's quite small. The answer given is C. C, 1 mm. If you put A as 1 mm, X, what do you get? If you put A as 1 mm, what do you get for the X? We put A as 1 mm. Okay, so let's say I could use the whiteboard. Okay. Okay, let's check the X lambda D A. The A, they say the answer is 1 mm. If you put A as 1 mm, so that means 1 times 10 power of negative 3. Lambda is 4 times 10 power of negative 7 meter. D was 2. How much the X you get? It's 8 times 10 power of negative 7 over 1 times 10 power of negative 3. So what do you get? 8 times 10 power of negative 4, right? Meter. X in centimeter will be what? In centimeter it will be, so 8 times 10 power of negative 2 centimeter, like 0.08 centimeter. Very small for A. Very small. Should be 0.01 mm. Makes sense. Okay, guys, I think let me check this question. This 30. Cannot be 1. Cannot be C, because the X we got is 8 times 10 power negative 2 cm. That means the fringe separation is 0.08 cm. Very difficult to measure by using a ruler. Smaller than, it's like 0.8 mm, like not even like 1 mm, very close. So not good. I think it should be A, 0.01 mm, according to this calculation. Okay, let me check back this question. I get back to you, Ashley. Okay, there is one past year question. They give a range. What is the range they give for the past year question? 0.5 to 5 mm. I think, do you remember the past year question? I go up, sorry, just for a while. This superposition, right? Okay. I show you the range and the range for the A value. There is one past year they asked about the suggest value. Quite. Yeah, this one. Suggest suitable value for the separation of slits in the double slit. Okay. So here the distance they didn't tell. Okay, it's for this one. Juno 3. Just want to show the answer. So this is the range given, 0.3 mm to 3 mm, 0.3 mm to 3 mm. Yeah, this is the suggested A value. Okay, fact to remember. But the problem is it depends to the distance. It depends to the distance, the D. We don't know what D they used here. Okay, if the D is 2 meter, so we want the A to be preferably in terms of centimeters. So this value can change. Okay, can change. But this is the average value they use for the setup. Okay, I get back to you the question, that particular question. So, but anyway, if in the exam they ask suggest a value, so you better suggest in this range, 0.3 mm to 3 mm. Okay, Ashley?
Yeah.
Okay. Any other questions?
33.
33, yeah. Okay, 33 circuit. what is the ratio of reading of A1 to reading of A2 in the circuit above? So A1 is placed here, A2 is in the main branch. It's a 6-volt battery. It has its own internal resistance of 2 ohm. You got 2 ohm. Oh yeah, here internal resistance 2 ohm. Here got 2 ohm. Here 6, 12. Okay. So what is the ratio of A1 and A2? Okay, let's say the main current is, let's say, I. Main current, the main current is I. Okay, the I when come to this junction, there is a junction I'm pointing here. The current is split into here the I1 and here the I2, let's say. Okay. Okay, the main current is I. We don't know what I, just I say I. When come to this junction, you're going to split to I1, I2. Okay. What current flow at A1? Is the I2, correct? What current flow at what current flow at A2? What current flow at A2? This is the main current, right? This is also I1. Here also I. It's going to be I, correct? The question asking for what? What is the A1 to A2? A1 divided by A2. That means the question asking for I2 over I is how much? I2 over I is how much? According to my diagram. Okay. Can you write I2 in terms of I or not? I come to this junction. I split into I1, I2. I1 greater or I2 greater? How much of fraction of I will go as I2? It depends to the resistance of that path, right? Like current come, let's say main current is flowing I. It's split into 2 branch. Okay, it's split into 2 branch, which has its own resistance. Okay. Okay. I say the first branch got 2 ohm. That path got 2 ohm, the first branch. Second branch, let's say, got 4 ohm. What is the current flow in 4 ohm? How many I? How many I flows to 4 ohm? How do you calculate this? The main branch current is I. It's split into 2 branch. One is 2 ohm, another one is 4 ohm. How much? How many I? How many I will flow to 4 ohm? So how do you find this? Did I teach you this? I think I teach you this shortcut. You take the opposite resistance. You take the opposite resistance for the current on top, 4 ohm. The current at 4 ohm. You take the opposite resistance 2 ohm 2 divided by the total resistance. Total resistance just simply L. 2 plus 4 6 times the main current I. This is how you find the current. The current at 4 ohm is actually 2 over 6. That means 1/3. 1/3 of I flowing to 4 ohm. 1/3 of I flowing to 4 ohm. This is how you calculate how much of fraction of current flow to a one branch. 4 ohm to ohm. How do you calculate? Take the opposite resistance 2 ohm, divide by the total resistance. So in this case 6 times the main current. And that's the current flow that path 4 ohm. Okay, use this idea. Use this idea, just now the fraction, the branch idea I told you. Can you write I2 is how many I? The main current is I, split into 2 branch. The I2 branch got how many resistance? I2 branch got how many resistance? 12 ohm, right? I1 branch got how many resistance? I1 branch got how many resistance? 6 ohm, right? Okay. Like if I adapt to this circuit, I can say like the main current is I. The one branch, the I2, as a path of 12 ohm. Another path is the I1 with the resistance of how much? 6 ohm. Can you write I2 in terms of I or not? How much is the I2 in terms of I? How much is the I2 in terms of I? So you take, how to get I2? Take the opposite resistance, how much? 6 over The total resistance how much? 12 plus 6, 18 I. This is the relation. I2 is actually 6 over 18 of I. In other words, I simplified become what? 1 over 3 I. So the current flow in I2, the A1 is actually 1/3 I. Okay, here 1/3 I. The I1 is actually 1/3 I. A1 reading is actually 1/3 I. A2 is I. So what is the fraction? A1 ratio to A2. How much is the fraction? So I ratio 1/3 I. So it's 3 to 1. It's 3 to 1. So answer is C. Answer should be C. Okay, Ashley, any part you don't understand?
I think okay, but then the answer is A.
Oh, they want A1. Yeah, they want A1 to A2. I did A2 to A1. A1 to
Okay.
A2, yeah, 1/3 I to 1/3 I to I. So you get 1 ratio 3. Yeah. So A. Yeah. Okay. But this is the concept to be used. This is the concept you use. If a branch got current split into 2 branches, so what is the current flow on top in terms of the main current? Use the ratio. Take opposite resistance over the total resistance times the main current. Get the how much of fraction of current flows there. Guys, the others, do you got the idea for this?
Sir, could you please explain the concept again?
Okay, this concept, huh?
Yeah.
Okay, let me ask you question again, huh? Okay, like for example, main current you got 2 ampere. Okay, you got one branch here 8 ohm. Another branch here 2 ohm. Okay, they're asking what is the current flow on top here? The I how much? The I flows up here. So I, the current flow up here. So you have to do the 2 ampere split into 2 currents. So let's say up one is I1, down is I2. Current flow here I2. Okay, without calculating, tell me the 2 ampere split into 2 current I1 and I2. We know 2 ampere is I1 plus I2. Tell me I1 greater or I2 greater? I1 greater or I2 greater? Which current going to be greater? The I2 will be greater, right? Why I2 will be greater? Because the path, the I2 path got only 2 ohm. The I1 path got 8 ohm. Big resistance, the current flow will be smaller. Okay, so if I'm asking what is I1, what do you do? This is a shortcut lah. Take the opposite resistance. Take the opposite resistance, 2 divided by the total resistance, 2 plus 8, 2 plus 8 times the main current, 2 ampere, is the current flow in I1. This is a shortcut. This is a shortcut for us. Always remember. Okay, so in this case, 1 over 10 times 2, 0.2 ampere is the one current flows here on top here, 0.2 ampere. 2 ampere when it comes to this junction, at 8 ohm path, only 0.2 ampere will flow there. The rest, 1.8 ampere will flow to 2 ohm. Okay, so this is a shortcut. If I put an, what do you call, this is I, this is R1, this is R2. Okay, if I'm asking what is the current flow at R1, in terms of symbol, I write R2 over R1 plus R2 times I. This is a shortcut for you to remember. Okay, this only works for 2 branch. Only works for 2 branch. Okay, sometimes they give 3 branch. Sometimes they give 3 branch. For example, let's say they give 3 branch. They say They said current I flow into 1 ohm, 2 ohm. Let's say this is 4 ohm. They're asking how much of current flows here across 1 ohm. Okay, you've got more than 2 branch, then this technique, the one I told you just now earlier, only works for 2 branch, only 2 branch. If they give more than 2 branch, what do you have to do? The branch they're asking the question, what current is flowing, you don't do anything to that branch. The other remaining branch, you have to merge. Make it, finally you make it like 2 branch only. That means what you do, this you must convert to here I, the branch where they asking for what current is flowing, that branch you retain, don't do anything. The remaining branch, the 4 and 2 ohm, right? You have to combine, and leave it as one single branch. That means the resistance here is 4 2 ohm in parallel. Don't simply add 4 and 2 6 ohm, because they are in parallel. Find the effective resistance in parallel first. So 1/4 plus 1/2, 1/4 plus 1/2 reciprocal. That's the resistance here. Okay. So then now you can use this method. So what is the current flow here? Now let's say you got a new resistance here R. So what is the current flow on top? The I1 will be what? The main current, the top resistance 1 divided by the total resistance 1 plus, sorry, not what I'm doing. The current on top is same as the bottom resistance R, the opposite resistance R, the total resistance R plus 1 times the main current. That's the current flow on top. Okay, this is the technique you have to follow. 2 branch, easy. More than 2 branch, the remaining one you need to merge so that you convert to 2 branch. Okay, this is what idea. Any questions, guys? This is who asked this question?
Me.
Genuine.
No, Pranav.
Pranav. Okay, Pranav. So you got idea?
Pranav.
You got idea?
Yeah.
So in the long method, right? If you don't use this method, also can, right?
Can. As long as what is the another method you choose? Oh, it's very long. Okay. As long as you got the correct answer, it's fine. You understand. This is another one way of doing it. Okay. I feel this short, aside the way I told you. If you go for a long method, I think how do you work out your long method? You find the current, is it? You measure the current. Or measure the current also can. Okay, any other questions?
$36.
36, 36, okay. Okay, 36. A generator produces 50 kilowatts of power at a potential difference of 10 kilovolt. The power is transmitted through a cable of total length of 3 kilometer. If the mean resistance of the cable is 5 ohm per kilometer, what is the total power loss in the cable? Okay, so for this we draw the circuit. Okay, the power station is like the battery. I put this is the power station, generator. So this is the generator. Okay, generator like a battery. Okay, so it connected to a cable. Okay, the cable and connected to a load. Don't know, maybe a motor. What we don't know what load they connected. The generator produces 50 kilowatts. The power of the generator is 50 kilowatts. 50 kilowatts, 50,000 watts it produces. And the potential difference is 10 kilovolt. Okay, the potential differences from here to here is 10 kilovolt. That means the battery has, like, imagine analog, the battery has 10 kilovolts. Okay. A cable 3 kilometer. The total distance of the cable is 3 kilometer. So this cable, last time we thought no resistance. Normally, normal circuit cable don't have resistance, but this is a transmitting electricity for households. It practically it has resistance. So it has 5 ohm for per kilometer. So 1 kilometer resistance is 5 ohm. That means the cable itself, we can imagine like this like the cable resistance. The total cable resistance how much? 1 kilometer has 5 ohm. 3 kilometer, the cable has a 15 ohm resistance. The cable has is 15 ohm resistance. Okay. And load, of course, it has its own resistance. We don't know. Okay, now the question is, what is the power loss in the cable? How much is the power loss in the cable? So power loss, of course, we got 3 formulas: IB, I squared R, V squared OR. So you have a cable. You want to know what is the power loss in this cable. These are the 3 formulas. But which formula is quite suitable for this question? Which information do you know? You know IRV. If you know any 2 of these information about the cable, you can use that formula. We know now resistance of the cable, we know is 15. So we're definitely going to use the formula with resistance. But now, do you know the current or do you know the voltage across the cable? What current flows across this cable? Do you know the current flow or do you know the voltage of the cable? I think easiest what you can find is the current. You can find the current in this circuit. How do you find the current in the circuit? You know the power of the generator is 50,000 watts and it's 10 kilovolt. So battery which has a power of 50,000 watts and 10 kilovolt, you can find the current produced in this cable. How do you find the current? P equals to IV. P equals to IV for the generator. P, it produces 50,000 watts and the voltage is 10,000, okay, 10,000 kilovolts. So current find be how much? 5 ampere. So the current flows in this circuit is 5 ampere. Okay. So now you can find the power loss. Power loss is, so the formula is suitable is I squared R. For the cable, the power loss in the cable is I is found to be 5 ampere, 5 squared, and the resistance is 15. Yeah, so you can calculate the power loss in watts. So 5 squared times 15 is the power loss. How much you get? 3,750. Yeah. I know 3,700. How much you get?
375.
375. That's answer. That's answer, right?
Yeah.
So you got an idea?
Yeah.
Okay, the others, please. Any part you don't understand? The others. So when a generator, they tell you the power, they tell you what voltage is generated. We can find what current is going to flow out from the generator. Okay, just P equals to IV. Okay, take it down first. 1 minute for you before we go to the next question. Okay, so any other questions?
37.
7. Okay, so 37. Let me clear this. Okay, so 37. The current in a component is increased uniformly from 20 milliampere to 80 milliampere over a time period of 4 seconds. What is the charge that flows during this time? Okay, so when, of course, what formula comes to your mind about current and charge is I equals to Q over T. This is the formula. But I think when I teach this, I told you when you plot I versus T, a graph. Okay. Let's say current is constant, 2 ampere flows at a certain time. The area in the graph is the charge. Okay, yeah. I versus T, if you plot the area in the graph is the charge. The graph method is very useful if the current is not constant when changing and they're asking for charge. What if the charge has been released? For like this question, 37. The current changed from 20 milliampere to 80 milliampere. So you can plot a graph for the imagination. The current starts with 20 and rises linearly to 80 and become 80, where the duration of how much? 4 seconds. Okay, 4 seconds time. So they're asking what is the charge flows during this period. So the area under the graph is the charge. So this is your charge. So you find the area. So trapezium of 20 plus 80 times the height 4. The answer you get is millicoulomb because I never changed the milliampere to ampere. So 100, 400, 200, right? 200 millicoulomb. Is it B? You got a B, yeah?
Yeah.
B, yeah? So you got idea? So when current change, draw the graph. Area in the graph is the charge. Or you can take what? Another method, you can take the average current. You can take the average current. 20 plus 80 divided by 2. So the average current is 50. So then you can use this formula too. So the charge is I times T. I is the average current. Average current. So 50 times 4. Also you can get the answer. 200 millicoulomb.
Sir?
But yeah.
Why did you use the graph instead of the formula?
If you use formula, because formula, the current is changing. Current is changing. If current constant, you can use that formula. But because current changing, the current you're going to implant here must be the average current also can. Average current can. So, but this 20 change to 80 must change linearly. Then the average current going to be 50. Straight line. Okay. Yeah. So average current can. Okay. So two method. I prefer graph because why I prefer graph? Because sometimes if it doesn't change linearly, let's say a question comes out in exam, they show you the graph. They show I versus T and it changed from 20. It's a curve. Let's say it's a curve changed to 80. The current doesn't change linearly, curve. They show the graph and they're asking what is the charge released during this period. So you should realize the area in the graph is the charge. Okay. So in this curve graph, if you take the average current as 50, wrong, because it never changed linearly. Yeah. So, but that's why I always stick with the graph. Graph area in the graph is confirmed charge. Okay, Riyad.
Yeah.
And so I prefer charge area. And the average current only for the linear change. Yeah. Okay, take down another 1 minute before we go to the next one. Okay, any other questions, guys?
21.
21, eh? Okay, we go to 21. Okay, 21. The moon is held in a circular orbit by a gravitational force provided by the Earth. The strength of the gravitational force the strength of the gravitational force is 2.1 times 10 to the power 20 Newton. Okay. And the radius of the circular orbit is 3.8 times 10 to the power 5. What is the total work done on the moon by the Earth gravitational force during one complete orbit? So they're asking for what? What is the work done on the moon by the Earth, by the gravitational force? Okay. So Earth is here, the moon is here. So Earth pulls the moon this way with its own gravitational force, but the moon is displaced like this with the distance here with the 90 degrees. So what is work done? Work done is what? Define work. Work is the product of force times the product of force and distance travel to the direction of the force, right? The force and the displacement is 90 degrees because moon always move 90 degrees to the gravitational force, right? Go around. Any moment, gravitational force acting like this, the displacement will be 90 degrees, right? And it makes a circle. So because the force and the displacement is always 90 degrees, so therefore the work done will be how much? 0. No work has been done. The Earth does not do work on the moon due to its gravitational force. What's the reason? Because the gravitational force is perpendicular to the displacement experienced by the moon. So it's 0, no work done. So these numbers all waste of time. Doesn't work. It's still be 0. What is the reasoning? The force and the displacement is perpendicular to each other. So work done is 0. Okay, Ashley, you got the idea?
Yeah.
Okay. Okay, so check the force and displacement. Is it 90 degrees? Okay, any other questions, guys?
16.
16, eh? Okay, 16. A stone falls from rest from height h. Which graph shows the variation of the gravitational potential and the kinetic energy of the stone with the distance fallen by the stone, assuming air resistance is neglected. Okay, which graph is best for when it dropped from a certain height? A certain line drop. Okay, how the kinetic energy change? Of course, kinetic energy going to rise. Yeah, kinetic energy going to increase, potential going to drop. But is it going to be a curve or straight line? That's what we need to check. Okay, first we check about is there got air resistance or not? Oh, no air resistance. There is no air resistance. This is important. If no air resistance means if the potential energy drop by 2 joule means kinetic energy must rise by 2 joule, right? So it should be symmetrical. The change in kinetic energy, change in potential energy should be change in kinetic energy. If potential energy decrease by 2 joule means the kinetic energy must rise by 2 joule. Okay, that means it should be a symmetrical graph. If EP is a straight line, EK also must be a straight line, must be like identical, symmetrical. So A cannot be the answer. The graph is not symmetrical. B could be. C also could be symmetrical curve. When potential drop by 2, the kinetic also rise by 2. So EP like little flattened curve with a certain gradient. EK also will increase by the certain gradient. Symmetrical line like a reflection at the center. D also could be the answer. But D wrong. D. EP should be maximum at the beginning. EP should be maximum. So EP should start on top. EK must start at the bottom. So answer either C or D, C or B. C or B. But is it going to be straight line or a curve? So we check EP graph. This is EP versus distance h. We need a formula. Can you get a formula EP in terms of h? EP is what? Equals to MGH what? MGH. MGH. Okay, MGH. So, but the EP is decreasing. You know, its EP is decreasing. Potential energy is decreasing. Okay, so if I put y equals to mx, the h is the x-axis, the y is your EP is your y-axis. So it matches with linear law. Y equals to mx. The gradient will be mg. But this should be negative law. It's negative because what? The potential is decreasing. So y equals to mx. So EP equals to mgh. The potential energy is linearly related to h. Linearly, straight line. Okay. So therefore, the graph should be a straight line. EP must decrease straight line. So therefore, B should be the answer. EP should decrease straight line because EP is proportional to h, a negative h lah, because decreasing. So it should be a straight line, not a curve. Cannot be a curve. So EP straight line means EK also straight line. Because EP drop by 2 joule means EK increase by 2 joule because no air resistance. So the best answer go for this question is B. Okay. A cannot because they are not symmetrical. Doesn't looks the same. They have to be same shape. C wrong because EP not a curve. It should be a straight line. D wrong. At the beginning, 0 distance. EP should be maximum. Start from the top to bottom. Okay, Ashley, you got the idea?
Yeah.
Okay, guys. So any other questions before we stop here? Okay, good. Lots of questions. Paper 1, you must get how much to get A star? Around 33 out of 40. You must do the paper 1 until you get more than 33. Okay. So currently you have your AS. You're going to sit for paper 1, paper 2, and paper 3. Paper 3 is practical. Okay. Currently we don't have enough experiment we done in the lab. So you know what Cambridge did the May June exam, the 2021 May June, your senior who set for AS. Some colleges they just set for paper 1 and paper 2. Paper 3 they never set because not enough practical. So the 100% mark was counted based on paper 1 and paper 2 only. Paper 3 they never sit. So your case still pending. We see how soon we can go to the lab, and if we have enough practical we can able to do before your trial, then most probably we will include your paper 3, but not decided yet. Okay. Okay. Any questions, guys? Before we stop? No questions, Okay. So please continue to the AS trial papers. Okay, we done here AS trial. Okay, the next class, next Wednesday? Next Wednesday, what I'm going to do? I go up here. I slowly go up after we done August 19. We done up to August 19. So we continue investigating up. So do another 2 papers. Yeah, I'll send you the AS trial August 19. We done just now, right? Okay, after that, another 2 papers on top. Just explore as much as you can from the bottom. Okay, any questions? So no questions. I stop here today. Any questions? No questions, Okay, guys, see you then. So see you tomorrow. Tomorrow we'll be doing circular motion again. The tutorial. Thanks.
Thanks, sir.
Thanks.